Your quiz tomorrow is going to be on factoring completely and solving. I want you guys to understand the difference between those two questions. If I ask you to factor completely, do I want to know what x equals? No. You just want to break it down as much as you can. If it says to solve or find the zeros, that's when you tell me what x equals. If you were to solve a question like this, you'd get points off because that's not what they're asking you. They're just saying here to factor completely. So what's the first thing we look for whenever we're going to factor? We look for a GCF. Is there a GCF here? What? 5x cubed. Agreed. I'm going to take out a 5x cubed. So I'm going to divide this by 5x cubed and this by 5x cubed. And I'm left with x squared minus 64. Good. All right, so now I say, okay, what do I have left? Can I factor this more? I have two terms. These are the difference of perfect squares. What times what is going to give me x squared? X and x. What times what gives me 64? 8 and 8. Is there a minus sign between these? Yes. So that means it is the difference of perfect squares. So I have my 5x cubed. That did not go anywhere, guys. But what do my two parentheses look like? X plus 8 and x minus 8. Does it matter where you put the plus and the minus? No, just as long as you got one of each. And that's it. Just factor completely just means, hey, break it down as much as you can. All right, again, GCF. If I'm going too fast or whatever, let me know. But GCF. Anything? 2x to the 6th, agreed. So if I take out 2x to the 6th and 2x to the 6th, I'm left with x cubed minus 8. Is that the difference of perfect squares? No. Is it the difference of perfect cubes? Yes. So this A is x. My B term is, what number times itself 3 times gives me 8? 2. Good. So let's think about what this pattern looks like. My 2x squared is still here. What is my first parenthesis? X minus 2. Perfect. Whatever sign is here goes in that first parenthesis. And then this is where it gets a little tricky. Then we take our A term and we square it. So x squared. What's the sign? Plus. I multiply A times B, which is 2x. And then I have plus my B term, which is 4. That second parenthesis, or that second sign back here, this one right here is always a plus. Because remember, you're squaring that number. That middle one is the one that's a little tricky sometimes. All right, questions? Can you go back to Sure. All right, we good? You guys okay? All right. Now. What's the first thing you look for? This is a little overwhelming. What's the first thing I look at? Is there a GCF? Is there one? Yes. Can I take a 3 out of everything? No, I can't? Can I take a 4 out of everything? No? Well, I have 4 terms. What should I try and do? Group it. Let's try and group and see what happens. It may not work. We might have to do P over Q, but let's just try. In my first set, what can I take out? 9x squared. When I do that, divide out 9x squared and 9x squared, what am I left with? X minus 3. Good. So when I take out the next GCF, or I take out the next common factor, what should my second parenthesis look like? It should look like x minus 3 if this factor is right. So what can I take out of a negative 4x and a positive 12? Negative 4. If we leave with a negative, take it out. Once I do that, guys, watch what happens. I'm left here with x minus 3. Our new GCF that we write one time out in front is our x minus 3. And then after I write that out front, what happens here? It gets its own parenthesis, 9x squared minus 4. And we say, oh, I'm so glad I got that done. Check. I have 2 terms left. Is there a minus sign in the middle? Yes. Is 9 a perfect square? Is x squared a perfect square? Is 4 a perfect square? Yes. What can I break down 9x squared into? 3x and 3x. And what about 4? 2 and 2. Awesome. So I have x minus 3. And then I have 2 parentheses that look the same, but the signs in the middle are different. What are they? 3x plus 2 and 3x minus 2. Yay! Good job. Guys, cut up. Ask yourself the same question every single time. What do they have in common? X squared. What else? A 3. So I'm going to take out my 3. Quick question. Does anybody know how you can tell quickly if something is divisible by 3? Yes. Add the digits in 432. What's 4 plus 3? 7 plus 2. 9. Does 3 go into 9? Then 3 will go into 432. I think I said 23 first, but whatever. Just a little side note. Okay, so 3x squared comes out, and I'm left with x squared minus, I'll do this quickly for you, 144. I'm left with 2 terms. Is there a minus sign in the middle? Yes. Is x squared a perfect square? What times what gives you x squared? X and x. What times what gives you 144? Perfect. Plus and minus, correct? Good job, guys. Again, we are factoring completely in these. There's no equal sign, so I'm not trying to figure out what x equals. You guys with? All right, here we go. Keep going. What do we look for first? GCF. No numbers, but what about letters?
X to the 4th.
X to the 4th. Good. I can take out an x to the 4th. So I'm left with 5x what? Squared minus 16x minus 45. Yep. I probably factor this differently than you guys do. So if Mr. Gilpin taught you a certain way, that's fine. This is what I do. If it makes sense to you, great. If not, no worries. You stick with your plan. But I'm going to say A times C. Right? Is that correct? What are the factors? What do I get here? How much? 5 times 5, 225. Good. What are the factors? I still have my x4 here. Of 225 that multiply to give me 225, but add to give me 16. Well, I know 15 and 15, right? Is that going to give me 16 if I add or subtract? No. What are some possibilities? Talk to me. Factors of 225. 25 and... Does 25 times 9 equal 225? Does 25 minus 9 equal 16? Yes? Okay, so watch. This is how I do this. I take my x and I put it in front of here. And it's going to be a minus 25 and a positive 9, correct? Because we're trying to get a negative 16 when we add. Do you guys agree with me? Now I take my a term and I put it underneath here and I put it underneath here. Okay, so I still have my x to the 4th out here. Does 25 divide by 5 nice and pretty? Yeah, so this is x minus 5. Does 9 divide by 5 really nice and pretty? No, so this just becomes the coefficient. It's 5x plus 9. That's how I factor when a is not 1. I was taught that when I was in middle school, and that just kind of stuck with me. If you don't do it that way, no big deal. You can do it the other way. There's a bunch of different ways to factor, but that's just what I do. Again, if you want me to go over it again when we're done, if you want to see other problems like that, that's fine. I'll show you, but that's just what I do. All right. First thing I look for is GCF. Somebody's going to tell me 8. What's 8 times 7? 56. That gets us every single time. The biggest number that goes into 54 and 16, guys, is just a 2. What can I take out letter-wise? X to the 4th, okay? So when I divide 54 divided by 2, it gives me 27. And then I have x what? X to the 3rd. Minus, what's 16 divided by 2? 8. Just 8. Okay. Is that the difference of perfect squares? No, but it does look like something, doesn't it? Difference of what? cubes. What times what is going to give me, what times what, I should say, is going to give me 27. So this is, my A term is 3x. And what is my B term? What times what gives me 8? 2. So let's talk about our pattern. That first parenthesis is going to have whatever is in our original. So it's just going to be 3x minus 2. Everybody agree? Now my second parenthesis, you square the first term. Watch, guys, it's 3x squared. Then you multiply A and B. So 3 times 2 is 6. This is going to give me plus or minus. Plus 6x, good. Then you square the last term. What's 2 times 2? 4. This 2 goes to the 3 and to the x. It's not just 3x squared. So what you have here is 2x to the 4th out in front. 3x minus 2, yeah. And then I have 9x squared plus 6x plus 4. Very common mistake right here. You forget to distribute that too. So if you need to put it in parentheses and then draw little arrows to remind yourself, go ahead and do that. Doesn't matter. It's smart if you do that. All right, when I come to number 7, the directions change. I see the word solve. But what else do you see changes? There's an equal sign. That means what does x equal? That does not mean just factor it completely. It means what does x equal? So if we're trying to solve this, what do I have to do first? I got to move this 12 to this side. I need everything on one side of the equation and set equal to 0. So 6x to the 5th minus 12x cubed equals 0. How many answers should I have for this problem? 5. Good. First thing we ask is there a GCF? Is there? Yep. What? 6x cubed. Perfect. So that leaves me with x squared what? Minus 2 equals 0. All right. X squared minus 2. Is that difference of perfect squares? No, that's not a perfect square. So there's nothing else to break down now. Now we just solve. So I set each piece equal to 0. I have 6x cubed equals 0. I have x squared minus 2 equals 0. Divide both sides by 6. Okay. So I have x cubed equals 0. And now I do what? It's the opposite of cubing. Taking the cube root. What number times itself 3 times gives you 0? 0. So I have 0. Do I have 0 more than once? Yes, I have it 3 times because what times what gives you that number? You just have multiplicity here. You don't see it, but you have it. Now over here on the second one, we're going to add 2 to both sides. So x squared equals 2. Now what? Take the square root. When you physically put the square root on, what goes in front of your answer? A plus or minus. So this is plus or minus the square root of 2. And there we go. If you forget that plus or minus, guys, you're forgetting part of your answer. So just make sure you're aware of that. Excuse me. All right, so number 8. Again, we're solving. Let's move everything to one side. So when I move this positive 18x squared to the left, it becomes what? Perfect. All right, you can notice some things here, or you can just factor like normal. This is a trinomial. What times what is going to give me x to the 4th? X squared, good. What times what is going to give me 81 when I multiply, but a negative 18 when I add? Negative 9 and negative 9, perfect. Now if I'm going to factor a little bit more, I notice that this is the difference of what? Difference of perfect squares. So x plus 3x minus 3. And this one is x plus 3, x minus 3. How many answers, guys, should I have for this problem? I should have 4, right? My highest exponent is 4. I should have 4 answers. So when I solve this, do you guys agree? I have x equals negative 3, x equals positive 3, right? X equals negative 3, x equals positive 3. Do I have 4 answers? Yes. But do I have 2 answers twice? Yes. I'm not asking you for multiplicity. You guys don't have to graph. It's literally just factoring completely and solving. So if you wanted to write your answer that way, you could. Some of you are like, can I just write my answer like this? Sure. Just make sure you have the work to back it up so I can see you understand that you have negative and positive 3, but more than once. Everybody okay? All right, scooting along, scooting along. Factor completely. Is there an equal sign here? No. So am I trying to solve and tell you what x equals? No. Make sure you understand the difference between those two kinds of problems. First thing we look for is a GCF. Okay, there's not one. So let's try and group. If grouping doesn't work, then we got to do P over Q, but let's hope grouping works. What can I take out of my first set of parentheses? Perfect. X squared, and I'm left with x minus 2. What can I take out of negative 16x plus 32? That will give me an x minus 2 in a parenthesis. Negative 16. Perfect. So when I divide out negative 16, I get x minus 2. So what is the new GCF that I write by itself out in front? Okay, you can write out the x squared minus 16 first if you want to. Or you can write it like this, doesn't matter. But that what they have in common, you only write one time. And now I look to say, let me just see if I can break this down a little bit more. What do you notice about x squared minus 16? It is the difference of squares, x plus 4 and x minus 4. That's not a pretty 4. How are we doing? All right, here we go. What's the first thing we look for? GCF. Factoring is such a repetitive thing. You keep doing the same thing over and over and over again. What number goes into all three of these terms? 2. Good. And I can take an x what? Perfect. So I'm left with x to the 6th plus what? 3x cubed minus what? Right, minus 10. Okay. So my 2x squared is out in front. I just have a trinomial. What's going to go in the front of my trinomial? What times what gives me x to the 6th? X cubed. Good, Jeremiah, x cubed. What are the factors of negative 10 that'll multiply to give me a negative 10, but add to give me 3? Plus 5 and minus 2. Perfect. Have I factored this completely? Yes. Is there a difference of cubes or some difference of cubes? No. Yes, there's an x cubed, but neither 5 nor 2 are perfect cubes. So you're done. Just leave it. Don't create any new math. What do I do here? Am I solving it or just factoring completely? Solving. I want to know what x equals, correct? Okay. So, what do I do first? Look for a GCF. Is there one? No. Well, Anybody notice anything? How can I get 16x to the 4th minus 8x squared plus 1? If I multiply a times c, you get 16 times 1 is 16. There's no factors of 16 that'll multiply to give me 1/2. Well, there is, or 8, but it doesn't just jump out at you, right? This is one of those special patterns. I don't know if you guys, did you talk about special patterns with Mr. Gilpin? No? All right, well, if you get a problem like this and you're like, oh, I don't even know where to start. Look at the ends. Let's try to think through this methodically. Is 16 a perfect square? And is x to the 4th a perfect square? Okay, what times what gives you 16? 4. And what times what gives you x to the 4th? X squared, okay. Is 1 a perfect square? Yeah, what times what gives you 1? 1 and 1. This is called a perfect square trinomial. Sometimes this will happen where the beginning term and the end term is a perfect square, and you can write it as such. Now, let me show you the difference between the difference of perfect squares and your trinomial. I got 1 and 1. How could I get a positive number when I multiply, but a negative number when I add? What would both of the signs have to be? They both have to be negative. In the difference of perfect squares, you have one sign that's positive, one that's negative. They're different. But if you have a perfect square trinomial, then the middle signs are going to be the same. The middle sign will always be what is with the middle number. If that was a plus, then there'd be a plus in both of them. So now you can just set this equal to 0. You could factor this a little more. Question? Yeah. You could factor this a little more if you wanted to. Can I? Is this the difference of perfect squares now? God bless you. What times what gives me 4x squared? 2x and 2x. What times what gives me 1? 1 and 1. All right, same thing over here. This would be 2x, 2x. This is 1 and 1. So my 4 parentheses would be 2x plus 1. 2x what? 2x minus 1. Then I get 2x plus 1 and? Good, very good. Now what happens? I set them all equal to 0. So this becomes x equals negative 1/2. This becomes x equals positive 1/2. X equals negative 1/2. X equals positive 1/2. Do I have multiplicity? Yep. What would happen at negative 1/2 and at positive 1/2 on your graph? If you were to graph it.
Isn't it like touch and turn?
It's going to touch and turn. It's going to bounce off. Good. But you don't have to graph, so don't worry about it. Don't freak out. Just saying. It's good to remember. Ay, ay, ay. I got a whole bunch of squares and cubes and all that stuff. What should I do first? All right, set everything equal to 0. Move it on over. So if it's negative on the right, when I move it to the left, it becomes positive and vice versa. So this is x cubed plus 2x squared, correct? Minus 25x minus 50. All right, GCF? No. Oh, how annoying. Let's see if this will group pretty. I'm going to take out an x squared, so I'm left with x plus 2, correct? What can I take out of negative 25 and a negative 50? Negative 25. Good. If you lead with a negative right here, guys, make sure you take it out. And then I'm left with x plus 2. So how many times am I writing x plus 2 out in front? Just once. And what happens to my leftovers? They get their own parentheses. It is the difference of squares. Perfect. X plus 2, x plus 5, x minus 5 equals 0. So I get x equals negative 2, I get x equals negative 5, and I get x equals positive 5. 3 answers. How many did I know I had from the get? 3. Now, some of you are going to say, can't I, at this stage, just go ahead and solve it? Move the 25 over, take the square root? Yes. The problem with that is, like, if you have x to the 4th minus or plus 64, you move it over, that sort of a thing, you're only going to discover the real answers. Mathematically, you won't discover if there's any imaginaries. We're going to get to that in the next couple lessons, so I want you to factor everything fully and then go ahead and worry about solving, because if you don't, you might miss an answer. Okay. Find the zeros. Is that a different direction from what we're used to? No, how do you find the zeros? What does that mean?
Just change the f of x.
Change the f of x to y, which then becomes a 0. You set everything equal to 0. Remember, zeros, solutions, roots, x-intercepts, all of those things mean the same thing. It means, hey, set equal to 0 and solve. So change that to a 0. All right, we're set equal to 0. Perfect. 4 terms. Is there a GCF? No, but let's try and group it. What can I take out of x cubed and x squared? X squared. I'm left with x plus 1. What can I take out of negative 4x and a negative 4? Negative 4. I'll leave x plus 1. So my x plus 1 comes out in front one time. And then what happens with x squared minus 4? It gets its own parenthesis, right? And we notice that x squared plus 4 is the difference of squares. Good. If this was a plus sign, could you factor it? No, it has to only be a minus. That's what our difference of squares is. If that was a plus sign, then your answer would be imaginary. So when I solve this, I get x equals negative 1, x equals positive 2, and x equals negative 2. How many answers do I have? 3. How many did I know I had from the beginning? 3. Good.
Can I use the vacuum?
Sure. I have one more. Can you wait 1 second?
Oh, yeah.
Last one. Finito. What do I have here? How many terms? 4. All right, so let's try and group it. Can I group? Okay, so I'm left with x squared. I take out the x squared, I'm left with x minus 4. And then I take out a negative 9, I'm left with x minus 4. You guys agree? Okay. So x minus 4, and then x squared minus 9. It is the difference of squares, so x minus 4, x plus 3, and x minus 3. So we have x equals what number? 4, x equals negative 3, and x equals positive 3. Agreed? Good. Good, good, good. Questions? Here, guys, write this one down. I want to make sure you guys see every type of problem that you could possibly see. What about if we have f of x equals x cubed minus 13x squared plus 23x minus 11? All right, if I asked you to list out all the possible zeros, right? If you list out possible zeros, that's that P over Q. It's the last term over the first term. So what would your possible zeros be? Plus minus what? 1 and 11. Whatever's going to make up this last term. Now, if it says to find the zeros or factor or whatever, you go about it the regular way. You would say, okay, there's 4 terms, there's no GCF, let me see if it groups. Does this group? No. Every problem that we did today grouped just perfectly fine, but there may be 1 or 2 tomorrow that don't group. There's nothing else you can do. That's where we have to do our P over Q. How do we do that? All it is repeated, what? Synthetic division. I'm going to start with 1, see if 1 works. So write out your coefficients. 1, negative 13, 23, negative 11. Bring down your 1. 1 times 1 is 1. Negative 13 and 1 is negative what? Negative 12, okay? Negative 12 times 1 is negative 12. 23 minus 12 is? Ooh, okay. 11 times 1 is 11. Negative 11 and positive 11 is 0. What did you guys just prove? That 1 is a factor. So you can tell me, hey, one of my x's is x equals 1. How many more are left to discover? There's 2 more. There's a total of 3. So what is left over here? Well, this is x squared. This is x. This is my constant. So it would be x squared minus 12x plus 11 equals 0. Now we're at the stage where we're at a quadratic. The highest exponent is a 2. Hopefully this factors. If it doesn't, then you gotta go ahead and use the quadratic formula. But what are the factors of positive 11? That'll multiply to give me a positive 11, but add to give me a negative 12. X minus 11. So what do I do with this stuff? I say, okay, x minus 11 equals 0, and x minus 1 equals 0. So I have here, one of my zeros is x equals 11, and one of my zeros is x equals 1. A lot of times, guys, you have to use the rational root theorem when you have multiplicity. You see how you had the 1 twice? So if you get a problem where it's 4 or more terms, and you cannot, there's no GCF, there's no grouping, whatever, just list out all the factors of the last number, plus, minus, whatever gives you the last number, and then just keep using synthetic division until you get 0 as a remainder. Does that make sense? We good? All right.